Alright, so if you are using your calculator, normal, CDF, okay, that's a function on your calculator, will solve for percentiles, the menu reads lower, which is the lower boundary, Z or value, upper boundary, Z or value, U is your mean, and that funky sigma thing is standard deviation. Okay, if you only have one value, use a very high or low number for the other boundary. The INV norm will give cutoff values or z-scores, area, and a percentile, mean, and standard deviation. If you use z-scores, use n of 0, 1. If you use actual data, the mean and standard deviation of the data will be mu and sigma, so mean and standard deviation. Yes. Yeah. Just a note, don't round until the end of a problem. Let your calculator keep all the precision. And so that's the last of those notes. We good with that? Alright, so switching over to the example page, packet thing. There's random ink spots because of the printer. Alright, so with these ones, we'll just work through as many as we can. Most of these do actually come out of the book, so I'll probably be able to just kind of give you book problems to go with these after that. I'm not sure if you'll have any today or not. It depends on what we get through and whatnot. But anyways, 2 athletes compete in a 2-event competition, shot put and a long jump. Chris threw the shot put 63 feet and Ryan threw it 66 feet. Chris jumped 27 feet 3 inches and the long jump, and Ryan jumped 27 feet. Is Chris or Ryan the better athlete? So ultimately that's what we want to be able to answer, but we aren't just going to start with that. We don't know just strictly by looking at it. We need to calculate some information. But I do want to start out with drawing my normal curve and just looking at it. So somewhere over here, just draw your normal curve. Okay, and this 27 feet 3 inches comes out to 27.25 feet. Okay, we'll end up using that in a little bit. So the normal curve. Okay, and then straight down the middle, we have the mean. Then we have 1 standard deviation away, 2 standard deviations, 3 standard deviations, and then same thing in the negative direction. Okay, so what we're really thinking about with this question is basically which athlete did better overall compared to his peers. Okay, we're going to use standard deviation to show how far a value is from the mean. Okay, values that are farther from the mean are obviously more rare. So a value that's 3 standard deviations above the mean is just as rare as one that's 3 below. Okay. Okay, expressing values in terms of standard deviation. Standardizes the values. Okay, and I forgot to type these in, but the mean for shot put is 60 feet, standard deviation of 3 feet. Long jump mean is 26 feet with a standard deviation of 6 inches, okay, or 0.5 feet. Okay, so just as a refresher, our formula for finding z-scores is z is equal to y minus y bar over s, which is the standard deviation. So basically we want to find the z-score for Chris for shot put and long jump, and then for Ryan for shot put and long jump. And then we'll use that to determine which one is the better overall athlete. So we have, let's see, shot put. We have the long jump. We have Chris. We have Ryan. Alright, so how would I set up my z-score for Chris for shot put? Z equals what? What was, yep, 63 minus, what goes next? 60 divided by, yep, 3. So that gives me 3 over 3, which is, okay, it's 1, so that's 1 standard deviation above the mean. Okay, let's go ahead and do the shot put for Ryan. I'll just set that one up. $66 minus 60 over 3. So that gives us 6 over 3, which is 2. So it's 2 standard deviations above the mean. Then how about the long jump for Chris? Divided by, yeah, so it's going to be 0.5 because 6 is in inches and we need everything in feet. So it would be the 0.5, and somebody's going to have to do that on their calculator because I don't know what that is off the top of my head. 2.5 standard deviations above the mean. And then my Z for Ryan for long jump. (27 minus 26 over 0.5). And that gives me what? 2 standard deviations above the mean. So who's the better athlete? Why? Yeah, so he's pretty consistently 2 standard deviations above the mean, whereas Chris is better in the long jump than Ryan, but Ryan is just better overall, an overall athlete, which is what it was asking. So we would say Ryan is the better athlete. Yeah, so it's supposed to be, yeah. It's supposed to have 2 little, like, dashes there. 0.5 feet. I just wrote the letters instead of the symbol. I was supposed to type them in, I just forgot. So I just wrote them in. Any questions about this problem? Feel okay with finding z-scores for the most part? Alright, so then next page. Just gonna for right now. Maybe. Alright, so a statistics class took a 40-point quiz. Sounds familiar. Results show a mean score of 30, a median of 32, IQR of 8, standard deviation of 6, min of 12, and Q1 of 27. Suppose your score is a 35. So what happens to each of the statistics if you decide to weight the quiz as 50 points and we'll add 10 points to every score? So, and I forgot to write in here, the original Y is supposed to be written in each of those boxes. Okay, and then in the top row of boxes, we're writing basically just the information that was given to us up here at the top, and that's going to be for all of them. We write the same stuff, so you can go ahead and fill in the top line of all the boxes with that above information. So your score, 35, mean 30, median 32, IQR of 8, standard deviation of 6, minimum is 12, and Q1 is 27. So you can write that in, all of them. Alright, so I need to figure out what equation goes in this box for the statistic and then figure out what happens to all of these things by doing it. Okay, so what happens to each of the statistics if I decide to weight the quiz as 50 points and I will add 10 points to every score? So what equation could I come up with in terms of Y that shows about me adding 10 points basically to every score? Your notes probably aren't going to help you. It's probably more of a common sense thing. What am I doing to your score? Yep, I'm just adding 10 points, so I would just put y plus 10. So I'm literally just adding 10 to all of these numbers here, except for IQR and standard deviation. Those don't get anything added to them because those are still going to stay the same either way. So my score now becomes 45, mean becomes 40, median becomes 42, IQR and standard deviation stay the same, okay, because they're not being affected by that, just by adding. They're not, let me explain this now. They're not affected by adding points. No, they're only going to be affected if we're like multiplying by something, basically. Then they're going to change. Because if I'm just adding, and I'm adding an equal number of points to everybody, that range is going to stay the same. Like, the range itself is moving, but that total range is still 8. And that's the standard deviation. All the values are changing, yes, but the standard deviation isn't being changed because I'm just adding points to it, and it's being added equally to everybody's. And I'll explain it more when we get down to the next part, where we are doing some multiplying. But if you'll see it kind of more in the second problem. We're getting ready to see it in this one. No, you're still multiplying everything, but you're not adding. See, adding keeps all your values the same. It just makes it move left or right based on if you're adding or subtracting. But if you're multiplying, it makes the values completely jump. Yeah. So your IQR would change because it's changing all the different possible test scores. Okay, so your min would be 22, and then Q1 is 37. All right, but now, so this is where you'll see it here. What happens to each of the statistics if I decide to weight the quiz as 80 points and double each score? So what would I be doing to my score? Yep. So 2y. So my score becomes 70. The mean becomes 60. The median becomes 64. IQR, yep, 16. Standard deviation. Min, Q1, 54. Okay, so this is why I was saying it'll be easier to see it here. So my mean and my score, I'm just going to use these two as an example because you can see it pretty clearly here. So the mean and my score were 5 off here, right? By adding 10, they're still just 5 off, okay? But then when I came down here and I doubled the score, the mean and my score are now 10 off. So doubling it would cause the standard deviation and the IQR to change because multiplying increases that distance from it, okay? But now, okay, and everything else just does exactly what the equation does. Now with this one, part C, what happens to each of the statistics if I decide to weight the quiz as 100 points and I double each score and add 20 points? Yep, 2y plus 20. So basically I'm taking these values up here and adding 20 to them. So what's my score? So my score is 90. The mean, median, IQR, 16. Standard deviation, 12. Min, 44. And Q1, 74. Okay, so in this case, I already had doubled it up here, so those values that I got for the standard deviation, okay, stay the same because I'm just adding 20. So now that adding 20 is not going to cause anything to happen with my IQR, my standard deviation. It's not going to change the number of values in my range. Okay, it's going to change what they are, but it's not going to change that distance between my Q1 and my Q3. Q1 and Q3 obviously are changing. Okay, we don't have what Q3 is, but we know what Q1 is. They obviously changed, but the distance between them is still the same, unless we're doubling. So basically, to kind of summarize everything up, we see that adding the same number to every value changes the center, okay, and individual values. Okay, so with the center we mean mean and median. Okay, but not the spread, which is IQR and standard deviation. Okay, but on the flip side, multiplying every value by the same number changes the center and individual values and it changes the spread, which is the IQR and standard deviation. Okay, and the center up here is still your mean and median. Okay, does that kind of make sense? A little bit? Okay. Alright, we'll do one more and then we'll probably call it a day. I might try to give you guys one out of the book that goes with it if I can find one that looks like these. Alright, so the next problem it's about Martha and her grades. So Martha scored an 80 on a physics test where the mean was 75 and the standard deviation was 5. Bob scored an 83 on a chemistry test where the mean was 73 and the standard deviation was 12. Who scored the highest relative to the rest of his or her class? Show your work and defend your answer. So I would start by drawing the normal curves here. So we're going to have one for Martha, one for Bob. Okay, we're told for Martha the mean was 75, standard deviation was 5, so that puts us at 80. We're told for Bob the mean is 73, standard deviation was 10, so that puts us at 83. Or wait, sorry. This standard deviation was 85, not 83. Which one? Yeah, it's in the middle, or it should be. It may not be drawn perfectly. Okay, the standard deviation for Bob was actually 12, not 10. Sorry, so it puts it at 85. Yeah, 73 in the middle. And then his score was 83. The standard deviation was 12. Okay, the standard deviation for Martha was 5, so her standard deviation is right there at 80. So basically, I want to find the z-scores for each one. So how would I set up my z-score for Martha? $80 minus $75. Over 5, so I get 5 over 5, which is 1. And how about my z-score for Bob? So we want his score. So he got an 83. Yeah. And then we had a standard deviation of 12. So that's going to be 10 over 12, which is what? Do that on your calculator. .83. Is it like .8383 or is it .83333? That one. Okay. Not that it really matters that much, but. So we have there two different z-scores. So the ultimate question was who scored the highest relative to the rest of his or her class. So who did better and why? Okay, Martha, so why? Okay, Martha did better relative to her class. Her score was 1 standard deviation above the mean, but Bob's score was only 0.83 standard deviations above the mean for his class. Because it's his score. He got 83. Martha happened to get the score that was exactly 1 standard deviation above the mean. So this is her score and 1 standard deviation away. The standard deviation for Bob's was 12 above the mean, was 1 standard deviation away, but he only got 83. He was only 10 away from the mean. So that's why. Just the way I wrote it was kind of confusing because I wrote the 83 like on the graph, so. Let's see. Trying to decide if there's a problem I can give y'all to do. I don't think we've done enough to really be able to do that. I'm just deciding if we can do one more problem. Let's go ahead and do one more example because I don't think there's really any that I can give you yet that we've done enough for to have you ready to do that. And then tomorrow I should be able to give you guys a couple to do. And that way I'll just give you some more time to lump everything together tomorrow. Alright, so the Virginia Cooperative Extension reports that the mean weight of a yearling Angus steer is 1,152 pounds. Suppose the weights of all such animals can be described by a normal model with a standard deviation of 84 pounds. How many standard deviations from the mean would a steer weighing 1,000 pounds be? So, how would I set that up? Yep. So Z is equal to 1,000 minus 1,152 divided by, yeah, it's 84. I wrote the wrong number. So what is Z? Yep, negative 1.81. So we would say that a steer weighing 1,000 pounds would be minus 1.81 standard deviations below the mean. Okay, so then the follow-up question, which would be more unusual, a steer weighing 1,000 pounds or one weighing 1,250 pounds? So we've already figured out what it is for 1,000, so we need to do the Z-score now for 1,250. So how would I do that? $1,250 minus 1,152 over 84. And what does that give me for my Z? Okay, so we'll just say 1.17. So which one is more unusual? The one weighing 1,000 pounds or the one weighing 1,250 pounds? Why? Yep. So the steer weighing 1,000 pounds is more unusual because it is farther from the mean. Than the steer weighing 1,250 pounds. Yes. Yes. Mhm. Let's see. I'm trying to make sure I don't have these problems like in here for later. Alright, so if you guys want to start on a problem, basically we did the first part of the cattle problem. This was problem number 17 in the book. So the ones that I'm going to add on for you guys to start looking at are 19 and 21, okay, out of your book. So 19, basically, it's saying that it's saying look at the mean and standard deviation. It's saying that we're hoping that they're at least 1,000 pounds. To see how much over or under the goal the cattle are, we would subtract 1,000 pounds from all the weights. What would the new mean and standard deviation be if you did that? And then if they were to sell the cattle at auctions for 40 cents a pound, find the mean and standard deviation of the sale prices for the steers. That's the rest of that's 19, and then 21. Suppose the auctioneer in exercise 19 sold a herd of cattle whose minimum weight was 980, median was 1140, standard deviation 84, IQR 102. They sold for 40 cents a pound, and the auctioneer took a $20 commission on each animal. Then, for example, a steer weighing 1,100 pounds would net the owner 0.40 times 1,100 minus 20 is equal to 420. Find the minimum, median, standard deviation, and IQR of the net sale prices. So see if you can see what happens to that. And that kind of combines in the problem we did with like the y plus 10 or doubling with the score. So see how y'all do with those, and then we can go over those. If you're not going to probably finish them, but I would like you to start them for the next 5 minutes, and then tomorrow you'll have time to do it. It's on page 130.